Hello everyone, today I'm going to introduce you the Airbus A350. The Airbus A350 is the most advanced commercial aircraft on the world, an aircraft that is made of 2.5 million components to construct. The goal of minimum fuel consumption and maximum flying range is achieved. It wings measuring 33 meters in length, 6 meters in wide. Horizontal tailplane has the span of 19 meters. Vertical tailplane has 10 meters tall. 53% of the wings were composed by carbon composite. It's 40% lighter than aluminum and allow more complex shape. Each layer consists of super thin plies of carbon fiber embedded in synthetic resin matrix, and there are several layers. The process of making wings takes several days. The wing can withstand airspeed up to 960 km per hour. Flap design is optimized to reduce vortex generation, resulting in better lift efficiency, and improve low-speed performance while reducing aerodynamic generated noise from the wings. A special droop nose is integrated into the inboard wing's leading edge. It helps aircraft remain flyable even at low air speed and also takeoff and landing.
Since the idea of flying machine has been made possible by the Wright brothers many years ago, human is now capable to travel a very long distance across the globe by means of flying through the sky. Now, ladies and gentlemen, we are going to take a very closer look at the primary control surfaces possessed by none other than the newest, modernized, long-range efficient A350 extra wide body by the Airbus. There are three control surfaces involved in the primary class, which are ailerons, elevators, and rudder. Each of these control surfaces are movable parts that can be found on major part of aircraft structure, such as ailerons on the wings, elevators on horizontal stabilizer, and rudder on the vertical stabilizer of the aircraft empennage. Ailerons provide lateral control about longitudinal axis, which they are hinge mounted on the trailing edge of port and starboard wings near the wing tips. They are moved by rotating the control wheel or side-to-side movements of the control stick. When pilots move the control wheels or the control sticks, the necessary system will convert control wheel or the control stick movement into electrical signals through transducers and relaying the signal to electronic control actuator, primary flight computers, and power control units to move the ailerons. Once operated, one side will move up and causing the other side to move down, and this is how aircraft roll to the left or to the right. The next primary control is elevators, which are hinge mounted at the trailing edge of the horizontal stabilizer. This control will provide the longitudinal control about the lateral axis, and it is normally adjustable by in the range of at least 6 degrees to 30 degrees to the horizontal tail. The control motion of elevators is gained from the movement of control stick, which it is converted into electrical signals by some component called as transducers and relay it to the electronic actuator, primary flight computers, and power control units to move the ailerons. The action of the elevators will cause the aircraft to pitch up if the elevators are up and pitch down if the elevators are facing down. The last primary control surface is the rudder, which it is hinge mounted at the trailing edge of the vertical stabilizer of Airbus A350. Rudder is a vertical control surface design that tends to apply your wing movement to the aircraft, and rudder also provides movement about the vertical axis. As the pilots push the left pedal, the system consists of multiple components will convert the movement from the pedal to the mechanical movement of the rudder and causing the rudder to move to the left and vice versa with the right pedal.
Today we will talk about the secondary control surfaces of the aircraft. Let's look at the secondary control surfaces. Unlike primary control surfaces, these are not mandatory in all aircraft. These control surfaces are used to improve the performance characteristics of the aircraft and also provide assistance in flying the aircraft. First, we will see the flaps. It is located at the trailing edge of the wing, and they are classified as high-lift devices on the aircraft. Let's look at the cross-sectional of the wing and flap in more detail. Flaps can only extend downward, and as it is extended, it provides an increase in wing chamber, which increases the lift forces created by the wing. This is the lift equation. When the chamber increases, the value of CL, or the coefficient of lift, will increase. Therefore, the lift will increase. Flaps will have more than one setting or angle of deflection, and it is used during takeoff and landing. These settings are also called as configurations. Flaps are locked in a particular configurations by the pressure brakes. During takeoff, flaps are placed in a small angle, and during landing, it is extended to maximum angle. So the flaps provide high lift at low velocities. The next secondary control surfaces we will look at is the slat. Slats are located at the leading edge of the wing. They're also classified as high-lift devices. Like flaps, slats can only extend downwards, and as it goes, it increases the wing chamber, which in turn increases the lift force because of the increase in CL. The main advantage of the slats is that it increases the stall angle, so any aircraft can fly at higher angle of attack. Like the flaps, the slats also have different configuration, and it is used during takeoff and landing. In some aircraft, when they are flying at higher angle of attack, the air is allowed to flow between the gaps of the slats and the wings. These are called as slots. The next secondary control surfaces we will look at is the spoilers. The spoilers are located at the upper surface of the wing. They are mainly used to reduce the speed and lift of the aircraft. The spoilers can only be deployed upwards, which spoils the airflow at the top of the wing, which increases the drag on the aircraft. Spoilers are used in flight to reduce the aircraft speed and to rapidly decrease the aircraft altitude. They are used in landing to rapidly increase the drag to stop the aircraft safely. The difference in spoilers extension during flight and landing is the angle of deflection changes. The next secondary control surfaces we'll look at is the tab. These are the primary control surfaces of the aircraft. The tabs are installed on the trailing edge of the primary control surfaces. Let's look at the horizontal stabilizer to understand the working principle of the tabs. This is the elevator, and this is the tab that is attached to the elevator. The tabs can be classified as balance tabs or trim tabs. First, let's look at the balance tabs. If the elevator has to be deflected downwards, the tabs have to be deflected upwards. The airflow will push the elevator and the tab downwards, hence the balance tab will assist in deflection of the control surfaces. So if the elevator has to be deflected up, the tabs will have to be deflected downwards, and the airflow will push the elevator and the tabs upwards. This is extremely helpful if the aircraft has a cable pulley system for flight control. Now let's look on the trim tabs. These tabs are controlled by the trim wheel and uses to reduce the pilot's workload. To understand this, let's consider the aircraft flying with a nose-up condition. The aircraft is set to be out of trim. For efficient flying, the aircraft must fly straight and level, which meant that the aircraft must be trim for a level flight. The pilots, however, cannot keep holding the control stick forward throughout the flight, so the trim tab becomes useful. Once the tab is deflected up, the elevator gets deflected downwards and the tab is locked in this position. The aircraft is now trim because the elevator will maintain a level flight without any pilot input. We have seen some secondary control surfaces such as flaps, slats, spoilers, and tabs. Depending on the aircraft requirement, one or more secondary control surfaces will be installed. In such cases, the Airbus A350 will have these secondary control surfaces. The aircraft contains 14 spoilers in total on both wings, 1 trimmable horizontal stabilizer, 12 slats, 4 adaptive droop hinge flaps, and 2 droop nose devices installed on the aircraft. Thank you.
Never gonna stay. 내가 지쳐 쓰러질 때까지